Okay. All right, guys. So as I said today during class, let's all, before we begin this video today, take a deep breath and just remind ourselves that this is only a quiz. So as I mentioned, a quiz is about 20% of our entire class grade, and all of your lab reports are also considered quizzes, and so they count towards your overall quiz grade. So you have plenty of quizzes, so do not let this become an overwhelming quiz, okay? I promise you, just focus on one thing at a time, practice tonight, and we should all do well tomorrow, okay? So with that being said, you're all awesome. Let's get to it. So if you're watching this video, awesome. You're doing the first step in terms of studying for this quiz tomorrow, which is amazing, right? So this is going to give you a pretty good advantage. And I also, if you stay to the end of the video or fast forward, then you're going to get a little bit of bonus into a little bit of insight into the bonus question that I have at the end of the quiz. So as you can probably already see, I have a couple of new ways of teaching this. So I decided to actually create kind of a map to show the different ways that we can use our calculations. So if you feel like you are totally lost, then this may be helpful. If you feel like you have a pretty good idea, then you may just want to refer to this if you feel like a problem is particularly difficult. Also, don't mind me, I have two cats and it's almost their feeding time, so they're going to probably be meowing incessantly soon. Okay, so let's first just take a quick look at these calculation conversion charts, okay, or this flow diagram that I have. So if we start off with grams here, then the way that we get to moles is we want to multiply by moles over grams, or in our case, we're effectively dividing by the gram to mole ratio that we calculate. So the grams to moles, our grams will cancel out and we're left with moles, therefore we get to moles here. If we wanted to go from moles to grams, we want to multiply by that molar ratio we calculate using the periodic table. So we take our mole value, multiply across, our moles cancel out, we're left with grams. Okay, so these are the first and foremost, the majority of the problems that you're going to have is just converting between these two values. All right, the next common occurrence is from moles to the number of atoms or molecules. So if we have moles, then we want to multiply by Avogadro's number to get to the actual number of atoms or molecules. Or if we want our moles and we want to divide by Avogadro's number to get to, if I have the number of atoms and molecules, then I can divide by Avogadro's number to get moles, right? We want to take a really large number, right? Usually if you see a problem that has, some number times 10 to the 20 something or other, this means that we are going to be dividing by Avogadro's number to get to moles, okay? All right. So moles of atoms. So in this case, if we have moles and we want to go to moles of atoms, right? Moles and moles of molecules are the exact same thing, right? When we say moles and moles of molecules, we usually mean the same thing. Now, if I'm trying to go to moles of atoms, then I just need to get to moles first and then multiply by the number of atoms, okay? Now, I guess I forgot to mention, I guess there is another way. We can go from moles of atoms to the number of atoms this way too, okay? All right, so with that being said, let's go ahead and dive into our first problem. How many moles of F2 gas are in a 50 gram sample of a F2 gas balloon? Okay, so I kind of had our flow chart here on the right. So let's take a look. So we're starting off in grams. So we're starting off here. So we're in grams, and we're trying to go to number of moles. So we're trying to go to moles. Okay, so here's our entire flow, right? We're going from grams to moles. So we are going to have to divide by the number we calculate in our periodic table. So everyone, quickly go to your ptable.com. Go to ptable.com and then find the atomic weight. You can pause the video here. All right, so if you're back, that means the atomic weight of F. So I would write this out on my problem, 18.99, or in our case, I'm just going to round to 19 grams per mole. But we're not dealing with just F, we're dealing with F2. So, hey, kitties, I told you they were going to come over here. Stop. So we're dealing with F2. So F2 is actually 38 grams per mole. right? So now let's set up our problem. Whoa, let's set up our problem. So always start with what you're given, 50 grams of F2. And like we said in our flow chart, we need to divide by this number, so 38 grams of F2 for every 1 mole of F2. And when we do this, grams of F2 cancel out grams of F2, and we're left with just moles of F2, which is exactly what we're looking for, moles of F2. So perfect. So 50 divided by 38 gives us 1.32 moles of F2 gas. Now, if you put 1.3 here, I would accept it. 1.5, or if you rounded that, that's a little bit unacceptable. So just round it to the nearest hundredth, and you should be fine. So hundredth, again, is the second decimal after the decimal, or second number after the decimal. All right, awesome. Let's move on. I went ahead and labeled this. So these are going to be your easier problems. So this is going to make up about 50% of your test, or your quiz, sorry. All right. How many grams are in 2.7 moles of CCl4? All right, so very similar process. We're starting with moles, and then we're going to grams. So if we're doing that, we're following this arrow here. So we're going to be multiplying by our molecular ratio. So we have 2.7 moles of CCl4, multiplying that by our molecular weight. So chlorine is 35.45 on average grams per mole, and carbon is 12 grams per mole. But we have 4 of these and only 1 of these. So our total, 35.45 times 4 plus 12 gives us 153.8 grams per mole. So this is the molecular weight of CCl4 molecule. So we're multiplying by 153.8 grams of CCl4 and dividing it by 1 mole, right? 1 mole of CCl4. So for every 1 mole of CCl4, for every 6.022 times 10 to the 23 molecules of CCl4, it weighs 153.8 grams. So if we have more than 1 mole, then our weight should be more than 153.8. So let's figure out exactly how much by. 2.7 times 153.8 gives us 415.26 grams of CCl4. Boom, shakalaka, we done. Fini. All right. All right, so again, not too bad. We just got to keep ourselves organized. I really want to see you work this out here. If you just write the total, that's fine, but I'd really like to see this steps. Okay, so just keep that in mind. All right, so these ones are labeled medium. The next two are medium. So how many moles of molecules are in 5.6 times 10 to the 24th molecules of glucose? Okay, so how many moles of molecules are in 5.6? So we're starting off with the number of atoms per molecule, or number of atoms and molecules. Whoa, okay. And we are going all the way to how many moles? Okay, so we're going from this to moles, okay? So how many moles of molecules? So if it's moles of molecules, we do nothing. We just have to do, the original calculation. So let's set it up. Always start with what we're given. Oh my gosh. 5.6 times 10 to the 24th molecules of CCl4. Make sure you include your units. I will take off. Please include your units. It'll help you in the long run. And if we look at our flow chart here, if we're trying to go 2 moles, we need to divide by Avogadro's number. And I'll show you why that makes sense in terms of dimensional analysis. So we're dividing by 6.022 times 10 to the 23rd molecules of CCl4 for every 1 mole of CCl4. Okay, molecules of CCl4 cancel, and we're left with just moles of CCl4, which is what we were asking for. So 5.6 second EE to the 24th, then divide that by 6.022 second EE to the 23rd, and we should get 9.299 or 9.3 moles of CCl4. That's it. We're done. All right, not too bad. All right, we didn't need to use grams at all because we didn't even come over here. All right, but that's going to change soon. So medium again. How many? I guess this should be considered hard. Hold on. Let's change these definitions. So this should be, I think, hard. This should be V hard. All right. So how many grams are in 6.3 times 10 to the 25th atoms of oxygen? Okay, so we're going from atoms of oxygen to moles, and then from moles to grams. So let's do it. So 6.3 times 10 to the 25th atoms of oxygen. So just atoms of oxygen. So not molecules, just atoms. All right, each oxygen atom. So we got to convert to moles first. So we got to divide by Avogadro's number. O for every 1 mole of O. So we take 6.3 second EE to the 25th, divide that by 6.022 second EE to the 23rd, and we should get 104.6 moles, 104.62 moles of oxygen. And then we're going to take that 104.62 moles of oxygen, and we're going to convert moles to grams using our grams to mole ratio. So if you look at the P table now, go find oxygen, pause me. All right, if you came back and you got 16 grams per every oxygen, you were absolutely right, 16 grams for oxygen. So we take that number, multiply by 16, and we get 1,673.86 grams of oxygen. That is our final answer. So 2 steps. Katie? All right, now, here's the challenge question. I want to give everyone a chance to try this one on their own. How many protons are in 50 grams of the isotope 19 fluorine? How many neutrons? How many electrons? All right. Pause me if you want to try this one on your own. This will be a bonus question. Okay, so let's tackle this. How many protons are in 50 grams? Always, always, always start with what you're given. 50 grams of isotope 19 fluorine, okay? And we want to convert this to protons. All right, number of protons specifically. So in order for us to get to moles of number of protons, I kind of extended out our little chart here. So we are starting with grams, so we're going to have to go quite some way to get to the number of protons. So it's going to take us a bit, so bear with me. All right, so we're starting with 50 grams. I'm actually going to make this a little bit smaller because I got to fit in a lot of different calculations. So you know what? Let's do it here. So we got 50 grams of F2. All right, and for every F2 molecule, F2 weighs 938, as we did before. 38 grams of F2 for every 1 mole. And I'm going to do this all in one line because at this point, if you're doing this problem, you know what you're doing, right? We don't have to keep hitting enter. And then for every 1 mole of F2, we have 6.022 times 10 to the 23rd F2s. And then for every 1 molecule of F2, we have 2 fluorine atoms. I technically could have done this before here. I just want to highlight that, but it doesn't matter because we're just multiplying them all. So 2 fluorine atoms. And then for every 1 fluorine atom, how many protons does 1 fluorine atom have? How many protons does 1 fluorine atom have? Go to P table again and check it out. All right. If you got 9, you are correct. So 9 protons. All right. So it's a lot of math, but let's do it. 50 divided by 38 times 6.022, second E to the 23rd, times that by 2, times that by 9, and we get 1.4 times 10 to the 25th protons. Okay, now that is pretty much it, but we do have some other parts to this problem, right? But I'm actually not going to work it out here. The only difference here is just remember isotopes are their atomic mass is considered only for the number of protons and neutrons. So if we have 9 protons, that means we have 10 neutrons. So this is 9 protons and 10 neutrons. And the electron count will be the same as the protons. So 9 electrons. So boys, what are you doing? Okay, so protons and electrons are the same, okay, because it's a neutral element. I could have made this negative, I can make this positive, I can mess with this problem however I want, okay? So be prepared for everything. But with that being said, that is it for this little bit of a review. Try your best, do as many problems as you can tonight. Just do the best that you can on tomorrow's quiz. I know I won't be there, but just do the best you can. I'm looking forward to grading them and seeing how we do.